This video is going to look at finding the gradient of a straight line, something you should already know how to do, and looking at what angle that straight line makes with our axes. This is going to be more useful when we start getting into some more advanced maths, when we start looking at trying to find the area underneath a line and that sort of thing. So our success criteria here are that we want to be able to recall and apply the gradient formula for a straight line, and apply the trigonometric ratios to determine the angle that that straight line makes with the x or y axis. So if you remember that our formula for gradient, which we refer to as m, and remembering that the equation of our straight line would be y equals mx plus c, so we're looking for that m, the slope of the line, is going to be y2 minus y1 over x2 minus x1. So if we're looking at this example here, we want to find the gradient of each line. We just need to know the coordinates of 2 points on that line. So this first point here is at -2, 0, and up here we are at 0, 2. I'm going to call this one point 1, this one point 2. So point 1 is going to have the coordinate x1, y1, point 2, x2, y2. So our gradient here is going to be y2, which is 2, minus y1 over x2 minus x1, 2 over, so 2 minus 0 is 2, 0 minus -2 is 2. So that gives us a gradient of 1, because 2 over 2 is 1. If we look over at our second example, this point is 0, 3, and this one is 2, 0. So our gradient is going to be, this is point 1, this is point 2. It doesn't matter which is point 1 and 2. It's always going to work no matter which way around you have it. I just like to work from left to right. So it's going to be 0 minus 3 divided by 2 minus 0. So we've got -3 over 2. That doesn't simplify any further. So our gradient there is -3 over 2. Now, when we want to find the angle that a straight line is making with one of our axes, so in this example, it's going to be the x-axis, we need to think about our trigonometric formulas. So there's a few things going on in this diagram that we'll look at in a sec. But if we think about that little triangle that's made with the dotted lines, we're looking for this angle here. And the two lengths that we're working with, so these two lengths here, we can think about those as our opposite and adjacent, and up here would be the hypotenuse. So if you think about the rule tan theta is equal to opposite over adjacent, our old trig ratio from SOHCAHTOA, our tan there, we're looking to see what are those two lengths that we can work with. If we know the coordinates of the points A and B here, then we can work out the distance in x between the two of them and the distance in y between the two of them. So our x distance is going to be the further point minus the close point, so x2 minus x1. The same for y, y2 minus y1. So if we think that the opposite side is y2 minus y1, adjacent is x2 minus x1, we can rewrite our formula as tan theta equals y2 minus y1 over x2 minus x1. Now that formula right there should look pretty familiar as being our gradient. So we can think that tan of theta is actually equal to our gradient. Now there we've only found the angle that's in here. But if we are to expand that to this bigger triangle here, those two triangles are similar triangles, and all you need to know about that, if you don't remember much, is that it's basically the same triangle, just scaled up. So even though the lengths have changed, none of the angles are going to change. This is still going to be a 90-degree angle. This theta is going to be the same as this theta, and this angle here is actually going to be the same because our triangle's starting in the same place. So the angle is never going to change. So here we want to work out the gradient of the line passing through the points 3, 2, and 5, 7, and then the angle theta that that line is making with the positive direction of the x-axis. So that just means that the angle, if we think about 3, 2 is about there, and 5, 7 is up there, our line's looking like that, we want to know this angle here rather than the angle it's making with the x-axis going negatively. So we want the angle with the part of the line that's going to continue further into the positive numbers on the x-axis. So we start with working out the gradient, y2 minus y1. So let's use this as 0.1, this is 0.2. So 7 minus 2 divided by 5 minus 3 gives us 5 over 3. So, 5 over 2. I know how maths works. So we know now, we've done the gradient, so we've done the first bit, determine the gradient. We know that the gradient is equal to the tan of theta. So if we want to work out just theta, we have to say, take the inverse tan of our gradient, and that is going to give us theta. So here, if we take the inverse tan of 5 over 2, that's going to give us a value of 68.20 degrees if we go to 2 decimal places using our calculator. And so that is the angle in there that our line is making with the positive direction of the x-axis. This third example, just like the second one, we're looking for the gradient of the line through 2 points and then the angle that that line makes with the positive here. You can see that because it's a line that's going to have a negative gradient, that angle with the positive direction of the x-axis is actually going to be obtuse. So when you think about the fact that we're using our trigonometric ratios to work this out, the angle that we find is always going to be smaller than 90 degrees because right angle triangle has a 90-degree angle. Neither of our other angles can be 90 degrees, otherwise they wouldn't add up to 180. So we're actually going to find this angle in here, which let's call it alpha. And to find theta, then, this our unknown, we're just going to do 180 degrees minus the angle that we find. So start same way, our gradient is going to be 5 minus negative 3 over negative 1 minus 5. That's going to give us 8 over negative 6, which we can simplify to negative 4 on 3. So we know that's our gradient. So now tan of theta is going to equal negative 4 on 3, our gradient. So theta, or in this case, actually, let's label this as alpha, because that's actually what we're working out. So alpha equals the inverse tan of negative 4 on 3. Plugging that into our calculator, you end up with a value of alpha equals 53.13 and so on degrees, because we're not going to round that until the end. So theta is going to be 180 minus that value. So 180 minus 53.13, we'd store that in the calculator to make sure that we don't lose any of those decimal places. And it's going to come to 126.87 degrees, rounded to 2 decimal places. So that's good. We would expect it to be more than 90 degrees because it's that obtuse angle there. And together they're going to make that full 180 degrees that is the x-axis. Finally, one little thing that I forgot when we were talking about our gradients. It's just good to remember if it's going this way, so going up from left to right, it has a positive gradient. If it's going down from left to right, it is negative. And then our two special cases. So if it is going absolutely flat from left to right, our gradient is going to be 0. And if it's going straight up and down, we call that undefined. Because when you try to work out the gradient, you would be dividing by 0, which is mathematically impossible. So those are just good to make sure you know. So if it is going straight that way or straight that way, it is a special gradient, and you're not really going to have to work it out. Also, if it is straight up and down, then obviously it's going to be a 90-degree angle with your axes, so you really don't have to work that out either. That's everything for this video. Hopefully it all made sense. If we look back at our success criteria, you can recall and apply that gradient formula and then apply our trig ratios, really only tan, to find that angle, whether it's obtuse or acute. If you wanted to do it with the y-axis, it would be the exact same process. You just have to flip it upside down, make sure you're using the right ratios.